what is a bomb calorimeter? Bomb calorimeter is an equipment used to measure the heat absorbed by the chemical reaction occurring at a constant volume or QV. This is nothing but the heat of reaction. A bomb calorimeter consists of a steel vessel called as bomb, which is capable of withstanding very high pressures. The steel vessel of bomb is immersed in water-filled insulated chamber. The purpose of this vessel is to provide insulation and to make sure that no heat escapes out to the surroundings, that is, out of insulated chamber. A thermometer is used to measure the increase in temperature of the water. Bomb calorimeter is also provided with a stirrer which maintains uniform temperature. The bomb is externally connected to an electric current source through magnesium wire which acts as a conductor. This provides electric current externally. An arrangement is made externally to allow oxygen gas to enter into the bomb vessel. Let us perform an experiment using a bomb calorimeter. A reactant food sample is placed inside the sample cup located in the bomb, which in turn is connected to external current source using magnesium wires. At a pressure of 30 atmospheres, oxygen gas is introduced into the bomb. Now, by switching on the electric source, the current is allowed to pass into the reactant sample, due to which the food sample is heated up, gets ignited, and this initiates the chemical reaction. Here, during the chemical reaction, the ignited sample combines with oxygen gas present in the bomb, undergoes combustion reaction, and thereby forms carbon dioxide gas associated with the release of huge amounts of heat energy. This heat energy liberated, shown as arrows, flows out through the walls of the bomb and thus heats up the water surrounding the bomb. The heated water causes rise in temperature as shown in the insulation chamber, which ensures that no heat of the reaction escapes out of the chamber. This heated water increases the temperature, which may be noticed by the rise in mercury level of the thermometer. Thus, the final temperature is noted down. Here, in the calorimeter, the reactants placed in the bomb acts as a system, while the surroundings is constituted by calorimeter and its components, that is, bomb, water, vessel, etc. In this entire process, one has to notice that there is no heat transfer occurring from system to surroundings. Further, the temperature change, referred as delta T, is related to the parts of the calorimeter, and the same may be equated by the following equation. Qcal, or heat gain by the calorimeter, equals to the product of heat capacity, or Ccal, and rise in temperature, referred as delta T. By moving delta T to the other side of the equation, the heat capacity of the calorimeter is given by Q divided by delta T. The heat capacity of the calorimeter Ccal is measured by burning a known quantity of reaction sample, which is generally benzoic acid. Actually, benzoic acid releases known amount of heat energy. For example, 1 gram of benzoic acid releases nearly 27 kilojoules per mole, which is nothing but Q. On substituting Q value in the equation, we get Ccal equivalent to 27 kilojoules per mole divided by delta T. Since no heat escapes out of the calorimeter, the amount of heat gained by the calorimeter equals to negative value of heat released by the chemical reaction taking place inside the bomb. Therefore, Qcal equals to negative value of Q reaction. As the reaction takes place at constant volume, Q reaction may be referred as QV, which is nothing but the change in internal energy, or delta E. Delta E may be calculated by following equation. Here in the equation, m is the mass of the substance, capital M is the molar mass or molecular weight of the substance, S is the specific heat, while W refers to the mass of the substance. By noting down the temperature rise in the thermometer, the change in temperature or delta T may be calculated. Knowing both Q and delta T values, heat capacity of the calorimeter Ccal may be calculated. Thus, one may conclude that bomb calorimeter is used to measure change in internal energy or delta E.